Hello everyone. In this video I will discuss about the principle of superposition. First we will see what is the application of principle of superposition. Many times a structural member is subjected to a number of forces acting not only at the ends but also at intermediate points along its length of the member. Let's see in the diagram. Member AE is subjected to a number of loads not only at the end points like A and E but also at intermediate points such as B, C and D. So in these situations we have to apply the principle of superposition. So next, what is the principle of superposition? The resulting strain will be equal to the algebraic summation of strains caused by the individual forces acting along the length of the member. So this is also have to saying that total deformation of a member equal to the summation of deformation of the individual members. So then deformation for the AE member, that is delta, should be equal to the summation of delta of AB plus delta of BC plus delta of CD plus delta of DE. We know that one deformation delta equal to the PL by AE. So similarly here total deformation delta equal to summation of PL by AE. So then it should be equal to, so deformation delta equal to P1 L1 divided by A1 E1 plus P2 L2 divided by A2 E2 plus P3 L3 divided by A3 E3 up to summation of Pn Ln divided by An En. Here we are considering that one. So area, cross-sectional area of the member is for the all the members it should be equal, and also the member is having the same material, so E is common. Then A1 A2 up to dash An should be equal to A. Similarly E1 E2 up to En, it should be equal to E. Then here 1 by AE have to take the common. Then it should be the summation of P1 L1 plus P2 L2 plus P3 L3 up to the dash Pn Ln. Here P1 is the net force acting on the first member, that is the AB, and L1 is the length of the first member, that is the AB. Similarly P2, P3 and Pn are the net forces are acting on the second member and third member up to the N member. Similarly L1, L2 dash dash up to the Ln are the length of the individual members. Next we have to calculate the deformation of a member AE by applying the principle of superposition. For this we have to calculate the deformation of individual members, that is delta 1, delta 2, delta 3 and delta 4, which means delta AB, delta BC, delta CD and delta DE by observing the free body diagrams of the individual sections. So first we have to calculate the delta 1, which means deformation for AB. For this first we have to draw the free body diagram of AB. So this is the free body diagram of the AB section. We know that one deformation, let us consider delta 1 here. Delta 1 equal to P1 L1 by AE. Here P1 is the net force acting on the member AB. For this we have to observe the left and right hand sided forces of the member AB. So left hand side forces are, that is, see here, left hand side forces, that is at point A. So total forces are acting only one force, that is 8 kilonewtons tensile. Similarly we have to observe the right hand side forces, that is at point B. So what are the types of forces are acting at point B? See here at point B, what are the type of forces are acting here? Here we have to observe that one. 4 kilonewtons tensile, 2 kilonewtons tensile, and 2 kilonewtons compressive, 4 kilonewtons tensile. And one more thing here we have to remember, if the member is acting with the tensile forces mean, consider the symbol is positive symbol, and when the member is acting with the compressive forces, then we have to take the symbol is negative symbol. So first we have to observe the here. So left hand side at point A. So only one type of force, that is the tensile force. So net force is positive 8. Similarly here, so right hand side at point B, 4 tensile mean 4 plus 4, and also 2 tensile plus 2, 2 compressive minus 2, 4 tensile plus 4. So the summation of this one is, so 2 and minus plus 2 and minus 2 will get cancelled. Here also we will get the 8 kilonewtons. So total net force acting on the section AB section is, that is 8 kilonewtons. And we know that one deformation is P1 L1 by AE. So here P1 value is the 8 kilonewtons tensile. So tensile we are getting mean, so the deformation also extension it will be takes place, though then we have to consider the deformation also, it is the positive. So total deformation of the section AB, that is the delta AB, equal to the 8 L1 divided by the AE. Next we have to calculate the delta 2, that is deformation for the BC member. For this, first we have to calculate the net forces acting on member BC. For this one, first we have to draw the free body diagram of BC. So here first we have to observe the at point B, what are the net forces acting at point B. So here we have to observe at point B what are the net forces are acting. Here, so 8 kilonewtons is tensile, and so we have to draw like this also, should be the effect is same. And so 4 kilonewtons compressive. Compressive mean minus 4. So 8 minus 4, then net force it will become the 4 kilonewtons. 4 means it's a positive mean we are considering the tensile. Similarly same thing, another end. So right hand side at point C, here also have to observe that one. 2 kilonewtons tensile, so which is the positive. 2 kilonewtons is the compressive forces, that is the negative, and 4 kilonewtons is the tensile is a positive. So net force is the 4 kilonewtons. So positive, it is the tensile. So P2 value or maybe net forces acting on the BC section is 4 kilonewtons. The deformation of the delta BC should be the equal to the P2 L2 by AE. So here P2 value is the 4 kilonewtons and L2 is the length of the section, BC section. So L2 and A is the cross section area of the BC and E is the Young's modulus of the material. So total deformation of the BC equal to the 4L2 by AE. So next we have to calculate the deformation of the section CD. For this one, first we have to draw the free body diagram of the CD. Then we have to observe the net forces are acting on the left hand side and the right hand side of the section CD, which means at point C and at point D, what are the net forces are acting. So first we have to observe at left hand side, which means at point C. So here we have to observe that one. 8 kilonewtons is the tensile and 4 compressive and the 2 compressive. So it will, which is equal to the 8 minus 4 minus 2, which is equal to the 2 kilonewtons is a positive mean, which is the tensile. Similarly, you have to observe the right hand side, which is at D. So here you have to observe that one. Two forces are acting. One is the 2 compressive, so which is first one is the minus 2 and 4 tensile, which is the positive plus 4. So total net force is the 2 kilonewtons tensile. So the deformation of the delta CD, which is equal to the 2 L3 by AE. Similarly, final member, that is the DE, we have to observe the deformation of the member DE. For this one, first we have to draw the free body diagram, and similarly same thing. First we have to observe the net forces on the right hand side, left hand side and the right hand side. So here also have to observe that one. First we have to observe the net forces are acting at the left hand side, that is at point D. Here I have to observe that one. 8 kilonewtons tensile and 4 compressive, 2 compressive and the 2 tensile. So which is the total summation equal to the 4 kilonewtons positive mean, which is tensile. Similarly, I have to observe that one at the right hand side, which is at point E. So here I have to observe that one, only one force is acting, that is the 4 kilonewtons tensile. So total extension of the delta DE equal to the 4 Ln divided by AE. So already we discussed what is the principle of superposition is. So the principle of superposition is saying that one, total deformation of the member which is equal to the summation of deformations of the individual sections. So previously we found the deformation for the individual sections, that is the AB, BC, CD and DE. So then delta equal to the summation of the all the deformation of the all the sections. So thank you.